Today, we're finally going to start learning Python. Isn't that so exciting? We're going to be talking about data types and functions, which are two of like the most fundamental things that you'll be seeing a lot of once we start actually using Python. What are we doing? So homework 1 is due tonight, I believe at 11:59 p.m. So please do submit that to the grade scope. If there are ever any questions, feel free to pop into office hours and we will help you out. Also, it is totally okay if like you're still working on things. You just need to make sure to let us know. So then we'll actually like be able to go and view your submission when you have a chance to submit it. Homework 2 is also now up on Gradescope, so y'all can start working on that one. It should be about GitHub and the command line, so just a little bit more of what we were working on these last few weeks. Our office hours are up and running, so if anyone can't make any of those times, you can always feel free to email us, let us know, post on Ed. We will make sure you guys get the help you need. Cool. So today is our first actual Python lecture, which is so exciting. The first thing we're going to talk about are data types. So we've been throwing around a lot of these words like strings, integers, and stuff like that the last few weeks. But today we're actually going to understand what they are and like, why do I have to put a text in quotes? Like all that stuff is going to make sense today. So what are data types in Python? Data types are basically a way that we store information in Python or in our computers. There are a bunch of different data types, but the most common ones that you'll see a lot are the ones up on the screen here. Integers are basically any whole number is an integer. So if you want to make something equal to 1, or you want to make something equal to like 2 million, they're all integers. A float is any decimal number. So if you have 2.0, 3.0, any of those kind of things with a decimal point, they're floats. A string is what you have all probably seen at least a few times when we like write any like sentence, any text, any of that sort of stuff, it's a string. So if I want to, for example, print hello world, remember how we put hello world in quotes? That's what indicates that it's a string. So that is what a string is, any kind of text. A list, lists are kind of intuitive the same way a list is a list in English. It's a collection of different objects. We're going to look at them in a lot more detail, so don't worry too much about exactly what each one of these looks like. Tuples are another data type they're like kind of like a set of items. And then a dictionary is a very fun data type that we will definitely be getting back to. What's super helpful about dictionaries is like you have this system that's a key value pair. So like, let's say you're trying to store information, like in a dictionary, you kind of know how to navigate through it. You look for a word and it'll tell you the definition. Similarly, a dictionary in Python, you look for the key and it'll give you certain information associated with the key. So that one is super helpful. And we won't be going super in depth today about dictionaries, but you will definitely be going to you're definitely going to see a lot of them in this class, and we'll be using them later on. Cool. Now, what is a variable? Hopefully in math class, we've all learned that a variable is a way to kind of save a value almost. That's the same way it works in Python. It's a way of storing information in the computer. We call this information data. And as we looked at in the last slide, this data can have different data types. So these are some examples of variables. So X here is a variable and it has the value of 7. Y is a variable and its value is the string some name. Z here is a variable and its value is the list of numbers 1 to 8. Something super important here syntax-wise. What do all 3 of these variable statements have in common? They have an equal sign. That is an assignment operator in Python. That is how you tell Python, hey, X's value is 7 from here on out. Yes.
Is that that only in the one Python file you have, or is it in everything ever?
Anything Python. You're saying like if I set x equals 7?
7 and you typed in X anywhere,
Mhm.
would it always
It would
be
only
7?
be in your specific Python file. So it's going to be local to your file, or your script or whatever. Yeah. Okay. So a double equal sign, very, very good question. A double equal sign has a different meaning in Python. Double equals means like actual equals to, like equality. So if you say 2 double equals 2, that is a true statement. Like for example, like you're actually comparing the number 2 to itself. But if you just say 2 equals 2, Python's going to be like, what the heck are you trying to do? Why are you trying to assign a number to a number?
So yeah, the equal sign is sort of like X represents 7.
Yeah. So you can think of it like, so X is what's holding the value of 7. You're assigning the number 7 to the variable X. Does that make sense to everyone? It's a little dicey intuition-wise sometimes, but you're going to see so much of it that it's going to start making sense really easily. Something that we would very, very much appreciate when you guys are working with variables, don't name them confusingly. Don't name them unintuitively. Like, for example, if you're like, I don't know, like if you have a list of numbers 1 to 8, like naming it Z, that's fine. But naming it list of numbers 1 to 8, that's descriptive and also fine. But if you name it something like sleigh, like we're not going to be able to track and understand it as we like go through your code. It's also going to be very helpful for you to remember what your variables are, because a lot of times you're going to use your variables, but it's not going to show you what that variable represents in every line of code. Yes.
So a variable can be anything. It doesn't have to be in a single letter.
No, a variable can be anything. I'll show you some examples. Oh, actually, let's do that. Let's do a demo.
Yeah. You guys are gonna think, I'll remember what this variable means.
You will not remember.
I promise you, you won't. Unless you have a really, really, really good memory, you will not.
Yeah, so descriptive variable names, very helpful. For you, for anyone looking at your code, it'll make a lot more sense. So everyone, let's open up our terminals and let's do some Python. Woo. Okay.
Should I turn off the light?
Yes, I think that would be probably better. Okay, cool. Yay, so we're in my terminal or command prompt or whatever. Wow, it's dark. Okay. All right, so what we're gonna do is we are going to define some variables. Figured? Okay. Can people in the back see? Yeah? Okay, cool. So how do we enter Python on our command line?
Python 3.
Perfect. So we're gonna type in, oh my God, if I can type. Python 3. Python is now we've opened up Python interactively on our terminals. So what we're gonna do is we're gonna create some variables and look at the types of these variables. So super simple example. Let's start with the first one. X equals 8. Yay. Now, yes.
If you put spaces between all of this stuff.
You don't, but it is like syntax wise, it is nicer to look at. There's a lot of things where like they're not necessarily, yes, you must do this, but it contributes to like coding hygiene. Like it makes things more readable. It makes things a lot more like if I just typed in like X equals 9 like that, like it looks fine, and it works fine, but also just, keep it consistent, keep it neat. Now, if I type in X, Python's going to tell me that it holds a value of 8. Does that make sense intuitively? X, we set it to 8, it's 8. Now, we're going to look at this really cool functionality in Python called type. If I do type X, it's going to give me class integer. What's that telling me? It's telling me that X is 8, therefore it's an integer, because 8 is an integer. Do you have a question? Yeah.
What do you mean by syntax?
Oh, so syntax is kind of just like the way you type things out. I don't know how else to.
The order of, so like we can think of variables, equal signs, all these things as like objects. Syntax is the order in which you put those objects. So between multiple coding languages, the syntax is different. So you're gonna be using the same objects like variables, equal signs, so on and so forth, but you're gonna be using them differently and they'll be in different orders. I think one of the most famous examples is that in Java, you need a semicolon at the end of each line, but in Python, you don't. In Python, you need white space at the beginning, which is just those indents that kind of happen.
These three.
You'll see those more when we get into loops and stuff.
Yeah, so it's kind of the way you would format something in a specific
I
program
think
language.
formatting is probably the best.
Formatting is probably the best way to like Englishify the word syntax, but it's like the way you format things, basically. Yeah.
So if you want to clear the variable x,
Mhm.
what would you do?
So, if you want to clear the variable x, one thing you could do is you could reassign it to, I don't know if you could reassign it to like null or reassign it to nothing. Or in my case here, because I'm working in like an interactive Python window, I could just type exit and the computer forgets. You can't delete things here, but if you're in a Python script, you can simply delete the line x equals 8 and then your computer will forget. Your computer will forget anything you don't explicitly tell it.
I said computers are really stupid.
Exactly. So that's actually a good segue into the next thing we can see. We can see that if so x is 8, right? In this next line, I'm going to set x equal to hello. Cool. Now that I've run that, if I put an x, the computer now knows x is hello. So it updates. So you can change your variables as, they go along. And now if I type in type of x, it's a string because hello is a string. I put it in little quotes. Was there a question?
Sort of, nothing you do is here is saved.
Nothing here is saved.
Okay, so if you didn't exit.
So let me, yeah.
Your window, nothing would be saved.
Nothing would be saved. So if I literally go, boop, and then terminal again, and I go into my Python again, let's zoom for everyone. Oh my God, Python 3. Now if I type in x, it's gonna be like, what the heck is x? It doesn't remember, because again, it's not saved. But if you're, for example, writing x equals 8 in a script, and then you're like saving that script, and then you're running that script, it's gonna remember x is 8 throughout that script. I hope that makes sense. Okay, cool. Fun. So we took a look at how to define a variable and how to find the type of a variable. Now let's look at something really fun that I think is going to be super useful for everything. So let's say I want to add two numbers together, but like I'm super lazy and like I want to keep changing the value of one of those numbers and like seeing how my addition changes or whatever. So let's say x is equal to 9. I'm going to do that, tell Python x is 9. I can also set another variable y equals to 2. Now if I do x plus y, Python's going to add them together. So you can perform operations on variables and it will basically operate on the values of those variables. Does that make sense? Cool. Another thing you could do is like set z to hello, for example, and then I can do z times 2. Wow, it printed hello 2 times. Yeah, so basically you can do these like funky, sometimes data types, you cannot operate on them together. Other times you can. And as we go through the class, that kind of intuition of what works together and what doesn't work together will make a lot more sense. Yes.
So in order to do what you were saying before, where you change one of the variables that you're adding, would you just keep changing, say, what x is?
Yeah, so I could literally keep changing what x is. I could say like x equals 10 now, and then if I do x plus y, it's going to print out 12 as like the updated result. And the reason this is super helpful is once we get into loops, you can see that you'll basically be changing a value over and over through a set of values. And that it'll make more sense then. Do you have a question? Yeah.
Like you can't add like x to 0, right?
Let's see. You cannot, because how do you add a number to a string? It doesn't make sense. But what you can do is set x to another string of, let's say 9, but this is type string now. So now if I do x plus z, it's going to tag on together. Does that make sense? Yeah. Cool. So that's just a little intro to data types. We're gonna see a shit ton of them and use them everywhere. So the most important thing to do when it comes to data type, oh wait, I can't clear on here, sorry. Yeah, so the most important things to remember are like the ways data types work together. And then if you're ever confused about what a variable's data type is, use the type function. So I could go into like this, I could go type Z and it'll tell me Z is a string. So that's always a super useful function. Mhm.
Okay, so is it that you can like do some operations with certain types together, like for
Mhm.
example, floats and integers,
Mhm.
or like, let's say, strings and integers, you can't like do operations.
So strings and integers, for example, you can't add a string to an integer, but like you can multiply a string by an integer and it'll like print out that string like multiple times, like how I did here with hello, hello. But you can't like, it's kind of like a weird like intuition you're gonna learn how to build up. Like you can do operations cross floats and integers, but like let's say you're dividing 9.0 divided by 3, the result is gonna be a float 3.0. It's not gonna be an integer. So like that's the kind of stuff that'll like appear and then you'll see it and you'll be like, oh, like it makes sense now. And then you'll see some patterns in that. Yes.
Let's say like this long, like this window with like a long bunch of like code text, whatever.
Mhm.
And you wanna identify one of the variables. Do you open up like a new window or something to like check that type?
As in like, you would have to do it in the same Python file. I don't really know what window means in this regard. Like,
I'm not gonna explain.
that's
Maybe
okay. Like another terminal type
Like,
thing.
let's say I'm in VS.
Yeah,
and I open-
like a new file. Mhm. So you're gonna have to do it in the same file. Yeah, because it only like, Python's just gonna remember in that one Python file. So each Python file, things can be, like you can have x equals 8 in one Python file, x equals 9 in one Python file. And when you run those files separately, it's gonna hold those two different values. Yes.
Could you multiply two strings together?
Let's try. Right now our strings, I think we have X is one string and Z is one string. You can't. Yeah, because like when multiplication kind of inherently is a numbers thing. So yeah, a lot of it is like, yeah, how do I multiply two words by each other? Like you'll like, build up that kind of like idea of like, you can't really do it normally. Python probably won't be able to do it, but you can always just try. Like fiddling and trying is almost like the easiest way to be learning this stuff.
Best way.
Yeah. Also something super important I want to call out to. Do you see that when I'm trying to do all these operations, Python does this really helpful thing where it tells you what's wrong with them. So here, for example, I tried to add an integer and a string. So it said type error. You can't use this operation to add on an integer and a string. So like once you are able to also, we'll be going into error messages and stuff in a lot more detail, but never be scared of errors in the sense that they will give you helpful information if you are able to read them and understand them. Like Python is going to tell you what's wrong most of the time. Sometimes error messages are unintelligible and then you kind of give up, but a lot of the time they're very helpful. It also will tell you where the errors are. So like, I know here it doesn't make as much sense because you're like coding line by line, but let's say you have a long Python file, you make a mistake on like line 4, it will tell you line 4, you have a type error. And then you can just go back and fix it. Yes.
Never mind.
Okay, cool. All right, so that is my little spiel on data types. Okay, do a quick check on time. We're looking all right. Okay, cool. So like I said, numbers, you have integers, you have floats. We looked at the type function. You put in the type of whatever your variable is. Does someone want to take a guess at what the output of this is? Yes. Exactly. It's a float because you see this little decimal point. And the moment you put a decimal point, it doesn't matter if there's anything behind it. It's going to treat it as zeros and it's going to be like, you're now a decimal. So you're a float. Good job. Cool. And then, so these are some operations you can do. Addition, subtraction, multiplication, division. we'll look into modulus, quotient, and exponent, I guess is pretty intuitive. Exponent, it's really really important to remember that it's not the little like caret symbol that we typically use when we type out exponentiation. It's 2 of the asterisks. The little caret symbol is like a bitwise operator. You don't want to be using that. It's going to be confusing. So anytime you want to like exponentiate something, you use 2 little asterisks. Cool. Yes.
For like the operations, like the modulus one, is it like the remainder?
Yeah, so modulus is exactly, it's the remainder. So if you do 10 mod 4, 10 divided by 4 is 8, but it has a remainder of 2, so the output will be 2. And then quotient will basically give you like the like this is called quotient, it's also called floor division. It'll give you like the whole number that it like divides to. So like for example, 18 floor divided by 5, it actually properly divides 3 times, so it's going to give you 3. Yes.
So if you wanted to find the, like 18 divided by 5, you wanted to find
The float,
the float, or the
like the whole
whole
answer.
number and the remainder.
Yeah, so then you would just use a normal division.
Oh, really?
Yeah.
You wouldn't do quotient and then modulus?
You could, but like the normal division will just output like the actual number.
Okay.
So like let's say I'm doing like 10 mod 4. So 10 mod 4 gives me 2, and then 10 floor divided by 4 would also give me, okay, what would that give me? That would also give me 2. But if I do like the division, it'll actually give me the decimal value of 10 divided by 4. Yeah. Cool. Characters and words. So strings are characters and words. The way that you know things are strings are you put them in quotes. As we said in previous lectures, you just want to be consistent about the types of quotes. You can either use single or double, it doesn't matter. But if you're creating something that has like a quote, like a little apostrophe inside it, then you want to use the double quotes. You can add together 2 strings. What that does is it just like tags on the second string at the end of the first string, combines it into a longer string. This is super important. So when you're doing things in Python, it's easy. Like when you're typically counting, you typically count going 1, 2, 3, 4, 5. So you would say the word hello has 5 like different spots, but Python starts at 0. So that's a really wonky thing that Python does, and most programming languages do. They are 0 indexed. So something cool that you can do is if you have like a string and you want to get the first letter of the string, you can do the string at. So when I say at, I mean with these little square brackets at whatever index you want. So the string at 0 is going to give me the first letter, which is H. And then the string at 5 is going to give me a blank space character because that's what's at the 5th position. Because if I count 0, 1, 2, 3, 4, 5 is like the white space. Does that make sense? This is something you're going to have to like, you're probably going to have like a million errors around because you like have forgotten how to 0 index, and trust me, it happens. It's just something that you got to keep in your mind. It always starts at 0. Cool. We actually looked at this, what happens when you multiply a string with a number, and it'll just print out 7 ones basically because you're multiplying. Yes.
Like if you have a string, but like let's say you wrote a sentence,
Mhm.
but then you put a full stop at the end of it. Would that count as a float? Or
No, because as long as it's inside quotation marks, Python's going to continue reading it as a string. So if you actually were to do something where you type in a sentence, you close the quotations on accident and then put a decimal point, Python's going to be like, what the heck were you trying to do here? Because this is not something I recognize. Yes.
Why would you need the number character thing?
Like a white space here?
No, why would you need to do the index?
Yeah. I don't know. Sometimes let's say that you're trying to organize, like you have a bunch of people and you want to organize them alphabetically. Or let's say that you are just like trying to find a specific, like, let's say you have a list of email IDs and you know how everyone's email ID has like an and sign in it. And let's say you want to split it being like, I want just their little like tag of their email ID, and I want to split it where I see this and sign. So there's a lot of instances where it might be helpful to actually just know where that is in a string. It'll be a lot more helpful in something like a list, for example, where you're like trying to find where something is in a list. So this is a list. You define a list by putting square brackets. You can also have lists inside of a list. So here, Berkeley and true forms another list inside my bigger list. And something that's really fun and funky about lists is you can have a bunch of different data types in one list. So for example, here, 4 is an integer, 7.5 is a float, astronomy is a string, and then you have another list inside it. And even in that sublist, you have 2 different data types. You have a string and you have something called a Boolean, which is just a true or false value that we'll revisit. Cool, and then indexing works very similarly in lists. So you can take 0 and that's gonna give you the first element of the list. Very, very cool thing you can do. You can negative index. So let's say I want the last element of something and I don't know how long my list is. I can just say, give me the -1 element and it's gonna tell me the last element. Give me the -2 element, it's gonna tell me the second from last element. That one's super, super helpful, especially when you have lists of lengths that you don't know or like different lengths, but you just want the last element. And then you can do something really interesting. These are called, there's a bunch of different words for them. You can call it a slice. That's what I like to call it because it like takes a slice of your list at the indexes you ask for. So for example, this is asking for a slice between the 2nd and the 5th index. So it's going to give me, because this is my 0, this is my 1. So it's going to be the 2nd, 3rd, and 4th element. Something super important to know with slices. The first number you put in the slice is your starting point. That one's going to be in the list. So it's inclusive of your start point. But the last index you put in the list, so here my 5th index, it's disclusive. So the start is inclusive, the end is not inclusive. It's not going to include the element in the 5th index. So this one's only going to hold the element from the 2nd index to the 4th index in technicality. That's just another weird syntax thing. Cool. And then this is just showing you that if you have a list, for example, 1, 2, 3, and you want to change the first number of the list, you can just do that by indexing it and setting it to a new value, and then your list updates. Cool. Yep, you can do math, but it's not like real math. Like if you wanted to do 3 times, if you want to get a list where it's like giving you, if you're trying to do like 3 times the list 1, 2, it's not going to multiply 3 times 1, 3 times 2. It's literally going to print 1, 2, 3 times. Sorry, that sounded really weird. 1, 2 is going to be outputted 3 times. So it's not real math. It's not going to actually like do like the distribution, but there are data types that will let you do that we will visit. Those are super powerful. We'll get there eventually. A tuple is again a different type of data. It's just another type of data type. We don't use them super, super often, but they're still good to be aware of because a lot of outputs are in tuples. And so they're usually defined by parentheses, and they kind of work similarly to lists, but I'm pretty sure that they're not editable like a list is. So like, you know how in our list here, we were able to set this 0th to 37 and then like update the list? You can't do that with a tuple. Yes.
What was the -1 for?
So the -1 is to get the last element.
Oh.
Yeah. So what this is basically saying is in my tuple here, I want to go into the last element because that's the -1. And then because this last element is a list, I want to set the first element of that list to 100. So what they're trying to do is get 1, 2, and then a sublist of 100, 4 is what the intention of that is, but it won't work because you can't edit a tuple. Cool. Dictionaries. So dictionaries, do I have another slide on this? I don't. Okay, so dictionaries are a really, really helpful data type. You create them by doing these little curly brackets. And the way they work is you have a key that's usually before this colon. So here the 2 keys that you have are stars and planets. Sorry, this is probably, yeah. So you have stars and planets, and those are your 2 keys. And stars holds this list of Sirius and Sun, and then planets holds this list of Venus and Saturn. You can see how helpful it is because if you have a ton of data, that you want to like organize like a key value pair. These are called key value pairs. Super helpful because you can just like look things up.
Are
Yes.
those things in quotation marks all strings inside of them?
Yes.
And
Those are all strings.
why?
Because it's storing like the names of stars, and anytime you want to store a word, you have to store it as a string.
Oh.
Yeah.
Okay.
Cool. So Booleans are one of the last data types we're going to look at. They're basically true or false values. So we're going to look at a lot more examples of Booleans. I'm a little short on time, so I'm going to have to run through this super fast. But basically, they tell you whether things are true or false. Pretty intuitive. So here, 3 greater than 2. What's going to happen? 3 is greater than true, so it's going to give me true. And then if I say, oh, this little expression here, exclamation point and equal to, that means not equal to. So 73 not equal to 9. It's going to give me true. So on and so forth. This is a fun little exercise where we have you guess what certain Booleans are going to do. I'm going to have to go through this super, super fast. So if you think that this expression is going to evaluate to true, put up a fist. If you think it's going to evaluate to false, keep your hand flat. You can just do it like right in front, so you like don't have to like put your hand up and be like wrong in case you are wrong. But it's also okay to be wrong. So what do people think true and true will evaluate to? Perfect. It's going to evaluate to true. And then you have other expressions like true or false. What do people think that will evaluate to? Okay. All right. So these are a little confusing because what does and mean? What does or mean? Like, yeah. So let's take a second to talk about that. So and or are, forget what you call, I think they are called operators, right? Yes. So they're operators in Python, which basically lets you like create expressions and check like different conditions. This will become a lot clearer when we go into conditional statements, which we will do next class. But basically what they do is, as you like kind of in English have an expression of a bunch of things, it's going to read through them and try to evaluate whether the overall expression is like a true or false. I'll give you a better example. Cool.
And is optimistic, or wait, and is pessimistic or is
Optimistic. Okay, so let's take a look at this example. 2 not equal to 2 or 1 equals to 1. What Python does, super important to remember, it reads left to right. So it's going to read this first thing, 2 not equal to 2. Is 2 not equal to 2? No, that's false. But because we have an or, it's going to keep reading. And it's going to be like, does 1 equal to 1? 1 does equal to 1, right? So you have a false or true, and that's going to give you a true. So it kind of works like that, where you read left to right. Each little sub-expression is a true or false, and then it will give you an overall true or false at the end as a result. Yes.
What if you had 2 not equal to 2 and 1 equal to 1?
So if you had 2 not equal to 2 and 1 equal to 1, you're going to have a false and true. And will only give you a true if everything's true. Because you're like, this needs to be true, and this needs to be true, and this needs to be true. But the moment it finds a false, you're like, okay, it's going to be false then. Because everything needs to be true in an and for it to be true. I know this is like really weird to say because it's like English and Python and you're like talking Python. But I hope that intuition makes sense. For an and, if you have a bunch of ands, everything needs to be true for the whole expression to be true. The moment it finds a false, it's going to be like, oh, false. For an or, it works the other way, where like everything has to be false for the overall expression to be false. Cool. So these are some interesting examples. What do we think will happen when we have true or 3 divided by 0 or true? Can 3 be divided by 0? No. So what's going to happen is you're going to get an error being like, I can't divide by 0. I can't run this expression. But if you try true or 3 divided by 0, you've already found a true. So or is just going to stop. It's like, oh, I already found a true. I don't need to run to the end of this line. It's going to give you a true. There's not going to be an error there. Yes,
So does the position matter? Like, if
Yes.
someone falls first and then true, false and false?
exactly. So the position is important because depending on whether it's an and or statement, it might not even reach the end of the line. And goes searching for falses or goes searching for trues. That's a good way to remember it. So or is optimistic. It's like, when am I going to find something that's true? Let's try to find something that's true. Yes.
But what if you type in 3 divided by 0 or true?
So 3 divided by 0 or true, because Python reads from left or right, that's going to error because Python can't divide 3 by 0. It's going to be like, I can't do that. Okay, I give up.
But it isn't
Fix
gonna
it.
continue searching.
It's not because
Oh.
you're going to get an error. Python is just going to try to read 3 divided by 0. It's going to break. It's going to be, I can't do this. Cool. All right, I'm going to have to run through functions kind of fast, but you will see them so many times that things will be clear. We've talked about basic data types, but like, you kind of don't know anything right now except for assigning things to variables and printing things out. How do you actually code? Like, how do you actually make things do things in Python? Functions. A function is kind of exactly what you think it is in English. You put in an input, you do something to the input, it gives you an output. Functions. Pretty English-wise, self-explanatory. But the way that you do it in Python, the syntax is a little interesting. So you do this thing called a def statement or a definition statement where you define this function, give it a name, and then you have to put in some inputs. Like, let's say you have a function that's adding 2 numbers. It's going to have 2 input variables, let's say x and y. And then it's going to do something. If you're adding, you're going to put in like x plus y here, and it's going to return that sum of x plus y. Does that make sense intuitively? So now if I call my function on these numbers 3 and 2, it's going to give me 5. And it's going to make more sense when I actually show you guys how to make a function and do like a little demo. But this is the general structure of a function. So for example, another, this one's pretty like split up and it has nice arrows, so it helps. You have a define statement. Something super important to note. Do you see how after this colon, there's like an indentation? That is really important. It's telling you everything that's inside this function. So the moment that you're indenting, you're like, all this stuff is inside my function. It doesn't like, and then if you're outside your function, it's not going to be like part of your function. It's just going to be like another line of Python code. So this indentation, super, super important. Let's write up a function, y'all. Okay. We're going to do this together. If there's at any point anything that people are like, I have no idea what's going on, put up a hand and we'll go from there. So what I'm going to do is create a Python file, open it up in my VS Code, and write a fun math function. Let's do this. ls. Okay, we're going to move into my Python DeCal folder, which you can do with the cd command. I'm going to clear because I forget that I have a lot of stuff on my desktop. Cool. So now I'm in my Python DeCal folder. Does anyone remember how to create a file? Perfect. So I'm going to create a file. I'm going to call it touchfunctions.py. Perfect. Now if I hit ls, ignore everything else I have in here. You see that I have a file called functions.py that I just created. Perfect. That's our first step. Now we're going to launch VS Code.
You
Just like look up VS Code in your Finder and launch it. So now I'm going to open that file I just created. So I'm going to go into the place I created it, which was my Python DeCal folder. And I'm going to open my file. Now I have a very nice blank Python file. Can you zoom on VS Code? Thank you, Megan. Cool. So now I'm in this Python file called functions.py. Let's write a function. What is the first step in writing a function? Writing out my function definition statement. So I'm going to say def. You know when it turns a color, it's good. Because that means like, okay, like this is a thing in Python that exists. So colors are always good. They tell you that things exist. So let's say, what do I want to call my function? I don't know. Let's say I call it, I don't know. I'll call it Slay. Slay is going to take in two things. It's going to take in two variables, X and Y. And what I want it to do, I'm going to write a little comment string that is reminding me what this function is doing. This is not actually going to evaluate in Python. It's just like, so I remember what I'm doing with this function. Is going to return the product of X and Y. So that's what I want my function to do. The way I'm going to do that though,
Yes.
we did talk about making variable names descriptive. So Slay is probably not a good example for this. See, I don't want to use product or multiply because they're already inbuilt functions. That's why I was like, let's just call it, can't use math either. Okay, I'm gonna call it mult. The reason I didn't want to use multiply or I didn't want to use product is because those functions already exist in Python and I don't want to overwrite existing functions because I don't want to break them. So we're gonna call it mult. So what mult is gonna do is multiply together X and Y. So what I'm gonna return is the product of X and Y. Does this make sense? Another way to write the same thing is you can have an intermediate variable to store the value of X and Y. So let's say I'm going to call it prod. The short form for product is going to be X times Y. And instead of returning X times Y, I'm just going to return product. Does this make sense to people? I'm feeling good about it. Okay, cool. So I'm going to save this file. I just hit Control S. The way that you know your file is saved is if you don't have this like little dot at the top. That means there's still changes to be saved. So I'm going to save my file, Control S. Or Command S, I don't know, on Macs. Just save it. Perfect. So I have my function now. It exists. So I'm going to show you two different ways to call this function. I can either make the function call inside this Python file. So I can say mult. I'm going to have to print it. So I'm going to print the product of, give me two numbers, maybe like 50 and 392. So I'm going to print this. And so what the print does is going to make it print in my terminal when I run this script. So I'm going to go back into my terminal, make clear because it's a mess. Does anyone remember how to run a specific Python file? Yeah, so it's going to be Python 3 and it's going to be the name of my file, which I forgot. Okay, so it's going to be functions.py. Cool. So that is apparently the product of the two numbers I put in. So my function is running. But do you see that, like, to make that function run, I had to put in this line where I called the function. I made a call to mult. I was like, you got to do your job on these two numbers. If I take this line out, I'm not calling the function. And if I rerun my script, it's not going to give me anything. Because I haven't actually called the function. I'm not telling the function to do work on any two numbers. It just exists there. So there's not going to be an error because the function is defined correctly, but it's not going to run. So basically Python is going to see my def state and be like, oh, someone created a function here. But because I never made a call to it, they're not going to actually evaluate that function. Another way to check whether your functions work, let's say you want to just do it straight on the terminal. You can also do that. You can just launch Python 3. And then you're going to do this thing from the name of your file. So the name of my file is functions. I'm going to import the name of my function. So what did I call my function? Mult, was it? Yeah, so I'm going to import mult. I'm going to run that. Now on my terminal, if I just call mult of, I don't know, 56, this will work. Does it make sense why? Because I'm using mult from my Python file, and then I'm calling it in Python. So there's two ways to do it. you either put it in your file itself and you're like print whatever result of this function, or you can just do it in your terminal directly by using this like from the name of your file, import the specific name of your function, and then you can call to that function. Yes.
When I'm trying to like run it, it's saying there's a syntax error expected colon.
Oh, yes. So do you see how at the end of my def statement here, there's a colon? That is super important because that's what's going to tell it, hey, everything inside here is my function. And then it's also going to auto indent it. It's going to automatically, if you hit enter, it's going to put everything as an indent. Yes.
In VS Code, I noticed that they have like, if you spell things wrong, they have little red lines.
Yeah.
Does that just indicate?
That's just a spell checker. That's
Okay.
that's not going to be, that's not like a code error. Cool. So does that make sense? To run a function, you need to make a call to it. So I called molt on these two numbers. So if I just did molt, for example, it's going to tell me that this function exists. There is a function, but I'm not doing anything with it. And if I called molt on like 8, it's going to be like, what's going on? You put in that 2 numbers have to go into molt. I can't do this with just 1 number. So you gave it an X value, but you didn't give it a Y value. So here, for example, when I define molts, you see how I gave it an X input and a Y input? So what this function is basically doing is assigning the value 8 that I put in to X. And it's like, where's the Y? You didn't give me a Y, so I can't multiply them together. So you have to tell your computer exactly what to do, otherwise it doesn't know what to do. Yes.
I tried to run it and I also got an error, but I mean, I have the
What? I can take a look at that error separately. What type of error does it say it is? Okay, so it's saying that you haven't defined your function correctly. I can take a look at that after, or yeah. Perfect. Yes. How do I open the Python file in VS Code? Oh, all I did was you can go here to the top, you can go to file, you can hit open file, and then you can just find the file that you're trying to open. You can also just create a new file on VS Code directly. You don't have to do touch on terminal. You can just make it on VS Code. It doesn't matter. It works the same way. Yes.
Also just edit the.
There we go. Yes.
You can do that. You can just use Nano and then create a file and then edit it on there. I just wanted to show y'all how to use VS Code because that's what you're going to be using for your homework. Yeah, because like doing all your homework in Nano, you could totally do that. No one's stopping you. But VS Code is a lot cuter and a lot more easy to navigate than something like Vim or Nano is. But yeah, you could totally just do it all in your terminal. Cool. Do functions and data types make sense? Are there any more questions about them? I think that's, I'm pretty sure that's it for me. Yeah, okay, cool. That's it from me today. If there are any questions, feel free to linger around, ask. We're all here to chit chat. Thank you so much. Make sure you submit your homework.
But if anything, like, you need to. Okay.